Utterly astonishing. Scientists have preliminarily solved one of the most important mysteries in the history of human physics. Where do the fundamental symmetries behind the four fundamental interactions of the universe actually come from? Nearly half a century of theory and experiments all point to a seemingly impossible answer. The chaotic effects at the deepest level of reality are, in fact, the true origin of all physical order in the universe. Even more shocking, the latest experiments also provide strong support for Nobel laureate Roger Penrose's proposal that human consciousness has a quantum origin. This series of major breakthroughs stems from a question scientists have been pondering for nearly half a century. Whether it is the Standard Model of particle physics, or Einstein's general theory of relativity, both are built upon symmetry. But where do these most fundamental symmetries actually come from? Why is the specific form of the universe's underlying rules a simple and elegant 1, 2, 3 rather than a vast and complex 5, 8, 0? The theoretical foundation of this year's latest experiment dates back 45 years, to a severely underestimated paper in the history of physics, titled Creating Light from Chaos. This paper first proposed a viewpoint that made physicists everywhere sit up straight. All the fundamental symmetries in today's quantum standard model actually originate from purely random chaotic phenomena at the deepest level of reality. So what is chaos? Let's look at a thought-provoking example. The motion of a pendulum is an extremely periodic and orderly behavior. But when you connect two pendulums together, that original extreme order gradually turns into extreme chaos. Here a serious question arises. This pendulum example shows that once systems become more complex, they tend to become more chaotic. So why did physicists claim in a 1980 paper that chaos, when taken to the extreme, can instead give rise to order? How does that order actually emerge? This idea resembles the ancient philosophical notion that things reverse at their extremes, but it is far more profound and astonishing. In the paper, physicists proved a key detail. Chaos at the deepest level of reality wipes out all redundant details. Only those features that can be amplified are preserved. And these very features are precisely the fundamental symmetries that support the orderly operation of the entire universe. Let's look at an intuitive example. At the beginning, every die has a unique face value, right? But when an expert rapidly shakes the dice, all face values are erased in the process. Then, after extreme disorder, when the shaking stops, you can clearly see all the dice standing upright, stacked one upon another, in perfect order. Returning to the paper, we can now intuitively understand why highly regular natural order emerges from chaos at the deepest level of reality. However, new ideas are often ignored at first by a conservative scientific community. As a result, physicists at the time did not give this viewpoint much attention. But nearly half a century later, in 2025, an experiment provided thrilling evidence for this paper. Researchers directed a beam of linearly polarized laser light into a glass container filled with nanoparticles. The nanoparticles move randomly and scatter the laser light. When everyone expected the scattered light to be completely random, an unbelievable scene appeared. The experiment showed that the direction of the scattered light was tightly correlated with the polarization of the light, revealing a strange form of order. Let me give you an intuitive analogy. Although the motion of each particle is purely random and chaotic, when each particle independently scatters the laser light, chaos does not destroy order. Instead, through massive statistical effects, like countless faint voices singing together, all irrelevant details are erased, causing the scattered light to form a clear and well-defined overall pattern. For the first time, physicists experimentally witnessed, through a classic example, the revolutionary idea that order in all things originates from extreme chaos. To make this even more intuitive, let's return to another strange experiment for comparison. When sand grains are sprinkled onto a thin membrane vibrating at high frequency, each grain begins to bounce randomly with no apparent pattern. But this extreme chaos does not last long. Very soon, you will notice that all the sand grains gradually arrange themselves into an extremely regular pattern. In this vivid example, we know that the reason order emerges from chaos is obvious. The membrane itself is vibrating with an ordered periodic motion. So now imagine this. That membrane is the spacetime framework of the entire universe, constantly undergoing intense quantum oscillations, or quantum fluctuations, causing all material particles within it to experience continuous chaotic motion. When particles interact with one another, the fundamental symmetries of those interactions emerge through the following mechanism. From this endlessly turbulent sea of chaos, in principle, particle interactions are observable by physicists. In a quantum world filled with random fluctuations, anything humans can observe must be meaningful only in a statistical sense. That is to say, any single interaction we observe is merely the collective manifestation of countless quantum behaviors. The most typical feature of such collective statistical effects is averaging. Therefore, if the fundamental interactions at the deepest level of reality are statistical quantum effects, then in the averaging process, all redundant quantum details are erased, leaving behind only overall physical features. It's like taking the average of the numbers 3, 4, 5, 6, and 7. They originally look uneven and different, but once we consider only their average, 5, we completely lose any sense of the original values. That remaining average, 5, is a manifestation of the overall effect. If we treat 3 and 4 as one particle, and 5, 6, and 7 as another, then the final number 5 symbolizes the interaction between the two particles. Of course, in the real quantum world, it's not just about averages. We must also consider the probability of every possible interaction, particle properties, vacuum fluctuations, and all physical factors involved. Here, you only need to understand one thing: the interactions at the deepest level of reality erase all details through statistical processes, allowing physical laws that humans can observe and describe to emerge. When expressed in mathematical language, they become the fundamental symmetries that govern all interactions in the universe, such as U1, SU2, and SU3. But chaos doesn't give rise to order only at microscopic scales. On the scale of galaxies, solar systems, and Earth, the stable order that has persisted for billions of years also emerged from chaos at their birth. We can even reflect on humanity itself. From the chaotic oceans of Earth billions of years ago, how did life gradually emerge, eventually evolving into today's highly ordered, intelligent human beings? Isn't this another example of extreme order emerging from chaos? Even more astonishing, scientists have found that research into order emerging from chaos has an incredible connection to the quantum origin of human consciousness. One of the greatest mysteries in humanity's self-understanding is whether humans possess free will. Science cannot even give a clear definition of free will. In this state of confusion, two theories stand out. One is the free will theorem proposed by the great mathematician John Conway. The other is a shocking idea proposed by Nobel laureate Roger Penrose, together with Stuart Hameroff, suggesting that human consciousness arises from quantum effects within large molecules called microtubules in the brain. What does this mean? The logic is actually quite simple. If humans truly have free will, then setting aside higher-level emotions and desires, the most basic feature of free will is free choice. That is, free will allows a person, when facing a fork in the road, to make an autonomous choice independent of the external environment. Penrose therefore proposed that, if human consciousness must ultimately obey physical laws, then perhaps the choices we make are actually caused by random collapses of quantum superposition states in microscopic particles within certain regions of the brain, triggering a chain reaction. In other words, what appears to be your brain making a decision may actually be a quantum component in your brain undergoing a superposition collapse, randomly choosing one path for you instead of another. After Penrose refined this idea, many scholars strongly rejected it. They argued that the brain contains too much noise and interference to maintain a quantum coherent environment, making sustained quantum effects impossible. Thus, the idea that consciousness originates from quantum effects in brain microtubules was considered untenable. However, this new experiment strongly suggests that quantum effects may not need to desperately survive within chaos. On the contrary, quantum effects may actually benefit from the brain's chaotic underlying environment, allowing the fundamental signals of consciousness to emerge. These signals are then amplified and combined through multiple layers of brain structure, interacting with countless internal models constructed by the brain in response to external input, ultimately forming the conscious experience humans perceive. Of course, regardless of the final truth, going even one step further would place us in uncharted territory. So let us evaluate the value of this theory and experiment, while bringing our own subjective experience of consciousness into the discussion. In fact, the intersection of quantum mechanics and chaos is not a new topic. Physicists have previously studied how noise can be used to maintain quantum coherence. Scientists once believed that any quantum system, such as a quantum computer, would constantly suffer from tiny random disturbances, from cosmic microwave background radiation, from minute vibrations in experimental equipment, and so on. These disturbances were thought to destroy quantum coherence. But this latest experiment shows that certain quantum effects can actually be amplified through random chaotic interactions. The significance of this is enormous, because the relationship between order and chaos may be the fundamental reason the universe exhibits so many astonishing natural laws. Look at the basic laws of the universe. They appear remarkably simple. The fundamental symmetries of the Standard Model are U1, SU2, and SU3. These are essentially the simplest symmetries humans have discovered. We can call them 1, 2, 3. For decades, physicists searched for larger and more complex symmetries, such as SU, 5, SO, 10, or E8. But all such efforts failed. This leads to an extremely exciting idea. Perhaps instead of searching for more complex symmetries, we should ask a different question. Why are the fundamental symmetries of the universe so simple? Why do we see 1, 2, 3 rather than 5, 8, 0? By now, you probably already have the answer. Because order emerging from chaos always tends toward the simplest and most elegant form. Consider the origin of life once again. Before life emerged on Earth, the chaotic oceans were brewing the order that would eventually give rise to life. And billions of years later, look at humanity today. The most essential bodily functions are embodied in the human body, with almost no redundant structures. Or take planetary motion as another example. We know Earth's orbit around the Sun is elliptical, but when you represent the centrifugal force at different points in the orbit, as vectors of corresponding lengths, you'll find that these vectors form a perfect circle. Why? Because once order emerges from chaos, it always takes the simplest possible form. Thus, the idea that order arises from chaos, supported by 45 years of theoretical and experimental work, is undoubtedly one of the most exciting foundational discoveries of the past half-century. In the future, this line of research is certain to lead to even more fundamental breakthroughs in physics.